Hello, everybody. I'm the author of the article 630, and I'm pleased to present to you the content in my paper. Please criticize and correct me. Thank you. My paper's title is Coping-Based Recognition of COVID-19 in Spatial Attentive ConvLSTM Recurrent Neural Networks. My name is Tianhao. I will present to you the main points in 9 essays in 4 parts. First, introduction, and second is method, third is equivalent, and fourth is conclusion. This is first the introduction. Deep learning modules can indeed convolutional signal filters relevant to fight against the disease yet the performance of state-of-the-art approaches is still severely restricted by the future information loss typical due to the high number of layers. To mitigate this phenomenon, defining the most relevant future versus background into attention mechanisms become essential. In this paper, we introduce Spatial Attentive ConvLSTM-RNN, and the short name is SACRNN, a novel algorithm that is using convolutional long short-term memory in recurrent neural networks with embedded attention that have the ability to identify the most valuable features. The promising results achieved with the fusion between the proposed module and the convolutional. Attentive convolutional recurrent neural networks on the automatic recognition of COVID-19 coughing. 53.2% of the unweighted average recall shows great potential of the present approach in developing the effect. Method I will introduce this 3 parts in method section. The first, the male spectrogram generation, and the second is the SACRNN frameworks, and third is connected with SACRNN framework. This is true. The 2-dimensional convolution are more efficient than 1-dimensional ones in small data size. 2-dimensional male spectrum are generated through the fast Fourier transform FFT from the audio signal in order to better capture the dynamic information of the signal. Data are also extracted from the Meyer spectrogram. This simple asset the simple rate of the average spectrum computed by passing the short-time Fourier transforms of the raw signal through the Meyer filter banks that obtain the Meyer spectrum. Subsequently, the logarithm of the generated Meyer spectrum is performed, and from the one-channel state log Meyer spectrums, data and double data are calculated as shown in the equation 1 to 3 respectively. This is the 3 equation to extract the state data and data future set to input our proposed module. And the main idea in our paper is SACRNN module. To build the proposed architecture, we first apply voice activity detection on the audio signal to count down the silent frames at the beginning and the end of the recording. Subsequently, we generated 3 times the Meyer spectrogram state data and data which will be used as input of deep learning model. The proposed module incorporates the CNN structure on top of the CNN RNN aimed to enhance the effect of the attention mechanism. In specific, the special block framework followed by a global average pooling layer and the soft layer is filled with the convolutional SACRNN framework. Not that the 2 branches module share the same convolutional layer as shown in figure 1. Before putting it in SACRNN, we filter extract filter use 2 layers CNN with scale connection scratchers, and then put it into SACRNN module as shown in figure 1. This is spectrogram state data and data we put it in the as the input to CNN with scale connections, and and divide two parts. The first part is SACRNN and conventional ACRNN. These two parts, and the final after the softmax function, we fuse them to get our output. Yeah, the output from STM are sent to the SACRNN and the ACRNN module. Impaired by the adder of image, we add the time access to output dimension of the convolutional layers which constitute a three-dimensional input tensor. Thus, the traditional LSTM is sent to the spatial module. By this, we expect the excellent performance of LSTM in processing continuous spatial matters attractively, while enhancing at the same time of the performance of the attention mechanism, which is able to capture more effective figures in the channel dimension. Note that we use the two-dimensional spectral message input to the attentive ConvLSTM layers, where in table 2 the module parameters shown with K is 2. Since we are dealing with a binary classification problem as a positive or negative symbol. Yeah, this is the parameter of the ACRNN module. Yeah, of the about three-dimension tensor space 128 channels in the spectral LSTM view. Definitely, you are both two-dimensions convolution kernels. And know that all boys can be learned. The whole structure is Shuo and the figure 2. Finally, the output of the Attentive ConvLSTM layers goes into a global average two-dimension layer and a softmax layer. Yeah, where this is the WA UA represents convolution kernel for X and HT1 representative. Yeah, this is equation 6. The equation is shown in the paper. After applying the teaching method, the new input goes to the LSTM layer by obtaining each parameter. The whole structure is shown. It's shown as figure 2. Finally, the output was attempted. LSTM layers goes into a global average 2D layers. Yeah, this is structure of the spatial attentive ConvLSTM network. As is input into the network based on two-dimension maps. The LSTM structure is used to complete the whole structure after extracting the spatial attention mechanism, so that the module retains its spatial information which will integrate with the temporal information retained by the ACRNN afterwards. Yeah, we add the other 10 dimensions in there. After ending the dimension, we get the five dimension in the SACRNN, the backside, and adding time step and time and the channel and the time steps and the Emilia is five dimension. Yeah, connected straight connected with the ACRNN framework. As for the ACRNN, the input of the module is again the output of the convolutional layers. As another branch of the output of the convolutional layers, we shape it into a shape of backside timestamp filters. Those filters are the multiplication between the Emilia and the channel. As the time dimension is retained as the timestamp parameters. In addition to this, in order to obtain the high-level filters through representation after employing the LSTM layer, afterward of the attention mechanism is performed for the timestamp. This is preferred. Instead of the simple performing a global average pooling over time in order to score the importance of the theory of the high-level representations. Finally, the all output from the above structure is sent to a 64 unit fully connected layers by this giving a high level representation. And the 3-part experiment. Yeah, data set described for our experiments a subset of the coverage COVID-19. Some data price as using the COVID-19 COV sub challenge from the Universität 2021 competition is computer EM. It's considered this data are collected in a crowdsourcing manner through the Covid-19 survey. APP had a length of 1.63 hours and encompasses a total of 929 samples produced by a 397 participants, each producing at least 3 samples to collect the data. Participants with both positive and negative COVID-19 tests were requested to provide false count. Results and discussion in table 3. Yeah, it shows table 3 shows our results. And module is trained with subsequent within the testing phase are considered to access whether the directions. Both is with one the real level with the proportion of sub segments successful predate working rule is complete if the proportions given the 0.1. The whole simple the prediction is considered as the real label at rest is regarded as the field clarification. Before training, the calculator of all sides is normalized by the overall average of variance of the training set for comparable along to the outcomes are achieved by the proposed architecture, result for the end-to-end learning and to-use approaches, as well as the results from the SACRNN and the ACRNN individual without also given to traverse experiments. The overall architecture was implemented with carrots, use the atom optimizer and stable momentum. Concerning the number of layers, different depth level were considered to find the normally configuration. Yeah, this is our result and discussion is shown in our paper. The result presented mechanism, sensitivity and specificity in the field module. Yeah, the conclusion. In summary, the SACRNN module preserves the spectral information of the audio signal, and the ACRNN module enhances the temporal information of the audio signal, and the conventional of the traces will evaluate on the given database. Yeah, in addition, fusion algorithm with connected hour for this module and the conventional ACRNN consists of a novel with potential applications in the speech classification text in general. In the future, one need. To be honest, our proposed module, due to the less of the database, the overfitting is incredible. So in the future, one needs to investigate a strategy to minimize the influence of the imbalance sample size in the module's performance, which has particular effect. The present study, besides the large amount of shocks, should be exploited for improving the general legibility and the robustness of the proposed module. Yeah, thanks very much. That's all. Thank you. Thank you everybody to watching my PT.